with day 11. We just solved day 10, and let's go to day 11 and let's hope that we'll get some interesting result. Oh, here I can see a lot of patterns. Probably we need to trim a little bit the input to make it more ChatGPT friendly. Let me start firstly new prompt. As previously, simply to give a short recap, we're solving all the problems using ChatGPT, Bin, and from time to time the OpenAI API in different ways. Sometimes we're making programmatic calls using HTTP quant. If we don't do that, we simply use this UI. Because of this UI, it's a little bit restricted in the version that we can code directly. However, all that said, we need to pay for that, and for that we avoid it as much as possible. And we solve most of the problems using ChatGPT Plus, of course. If you haven't subscribed for ChatGPT, I mean, you should support them. Also Bing, and we structure our projects pretty straightforward. We have it's a Go project that actually have in each folder main file. That's actually our program. We have the input and we have test input that we're testing with, and we have like a prompts file, markdown file, in which we save the prompts that we gave and the answers that we got from ChatGPT, Bing, etc. And that's roughly set. Let's start with firstly copying the day 10 part 1. Simply don't want to do all that stuff from scratch. We're renaming the folder track, everything perfect. We're going to the input is not anymore this input. We're going to the test, it's not anymore this one, and we are going to the initial prompt, and we are simply getting here. Initially, what we have noticed solving previous problems is that we need to have one prompt in which we are giving context of the model. Simply we are imitating these system messages that the new GPT 3.5 Turbo allow us to set up context, saying okay, your assistant in online shop, or your some support person that it's IT support and etc. In our case, we're saying okay, we'll give you this Advent of Code 2021, and there are some kind of questions and so on, but we want firstly to keep in mind that you're a prominent competitive programmer. You have been invited to participate in a programming competition, and you need to solve their problems. We are giving that as a initial input, simply to set up the stage, and the model is saying okay, blah blah blah, great, they're very satisfied, and they're asking for the problem. So to say, we are on a stage in which the model is asking us, which is perfectly fine. what we're saying are our instructions, and as you can see from Google Google Microsoft Copilot, the instructions we gave are already autocomplete for us, because we've been doing that the last um, 10 days. Write a Go program that solves the problem and read the input from a file, and we're giving the test file because we're using it to debug it. After that, we continue with the task, we give the task, and that's so to say our input. However, as we probably will take a look at this example, let's read it in a little bit, get the idea what are our requirements. You enter a large cavern full of rare bioimmune essent bimbo octopuses. Simply to give a context, we are in a submarine. We are at a cave that is at the bottom of the ocean, and we've been trying to navigate in this cave, and we've been pushed there by some ocean animal that attack us, and we needed to escape and so on. And at the moment we are trying with our submarine to simply escape from this animal and navigate through the caves. And this octopus seems to not like Christmas lights that we have on our submarine, so you turn them off for now. Okay, our submarine is dark. There 100 octopus arranged neatly in 10 by 10 grid. Each octopus slowly gains energy over the flashes brightly for a moment when its energy is full, although your lights are off. Maybe you could navigate through the cave without disturbing the octopus if you could predict where the flashes of light will happen. Okay, we have these octopus that are emitting light, and they have like a strength with which they are emitting this light. Each octopus has energy level. Your submarine can remotely measure the energy level of each octopus. Your puzzle input, for example, our puzzle input is saying, okay, this octopus that is on column 0, row 0, have 5, the following one 4, etc. And it's probably, as I can see, it's from 1 to 8. I couldn't see 9s. Let's see. The energy level of each octopus is value between 0 and 9. We simply here don't have zeros and 9s. Probably there is some trick with these values that our test input doesn't have, and because of that we can make some mistakes that they then show the complete input specific for me. We'll have these values, but we'll take a look of that later on. Here are the conditions. Now, here the top left octopus has energy level 5, as we said. The bottom right one has energy level 6, this one, and so on. You can model energy level and flashes of light in steps during single step of following occurs. First, we need to increase the level of each octopus by 1. We have our grid. We're passing through all of the levels, and we increase them by 1. Okay, for that our initial grid didn't have nines. Then any octopus with the energy level greater than 9 flashes. This increased the energy level of all adjacent octopus by 1, including octopuses that are diagonally adjacent, which means here would be all of the surrounding octopus. This process continues as long as a new octopus keep having their energy level increased beyond 9, which means that if some of my adjacent are 7s, they will become 8s and so on, and will continue. If they get to a level 9, an octopus can only flash at most once per step. Finally, any octopus that flashes during this step has its energy level set to 0, as it uses all of its energy to flash. Okay. When we increase their levels and they get to a level of 9, they flash, and after that they're reset to 0 as a final pass. Adjacent flash can cause the octopus to flash on a step even if it begins that step with very little energy. And the reason for that is because there can be a propagation of all the adjacent flashing, so to say, etc. And here are examples of that. Okay. And I need to count how many flashes been after 100 steps, considering this input. And that's our, so to say, task. The first thing that we need to do is to cut a little bit of the task description, because they're perfectly fine for me and you, but not for ChatGPT, because they're grabbing too many tokens, and also not sure how well it's performing from that. We can see it's already double the size of what's the allowed input for Bing, and it's getting too many tokens. For ChatGPT, what can we do is let's reduce some of the information. This blah blah blah, we can keep it. We have after step and so on. Here is how large example progress. We actually don't care for this large example. We don't want to see how large example progress. We can simply delete our large example. I'm being very satisfied with not having our large example, because that's how many flashes are. Again, our large example can be simply deleted, blah blah blah. And we can see that our token size and so on, it's significantly more reasonable. Okay, we have that as a input in our case, and let me paste it here. And we want the Go program. We have the task. We simply need to copy the task and to give it to ChatGPT, and we can discuss when we see the input. Okay, ChatGPT is unfortunately writing some stuff we don't care. For that, let's hope that we'll get a program. What we are doing is, when we get this description for ChatGPT, we want to actually get a legit program. And let me go on program. Let's little bit adjust the instruction, because it seems like ignoring this go thing. We actually want complete program. We don't want to hear blah blah blah. Yeah, it's again instructions. Probably if I swap that task, and if I put that like the one thing that should have attention about, okay, it's telling me about the program. I can see that it's writing the program, it's scanning the thing, doing some input, it's flashing, and it's getting cut because it cannot do more than that. Let me first correct my input. That was exactly what I put there. Why I did that? Because in previous examples we have seen that if I start going back and forth, and I start asking, okay, please write for me the program and so on, and going it step by step, because how limited ChatGPT is, so to say, it's modeled based on this large language model that actually have very little real memory, and it's more based on this tension and taking parts of the input as a whole, although has this context. I would assume that this context being implemented like simply being some kind of special token at the beginning of each of your messages, and keeping it there, and have some kind of summary of everything happened so far. At least that's what I can say from my previous observation. It's turned out that simply asking the same question a little bit rephrased, and simply asking for getting some kind of programs multiple times, it's much better than asking for a given program to be correct, like in this example, for example, saying, oh, here that and that it's wrong, can you fix it for me, and so on. It doesn't seem to work whatsoever. For that, my advice is simply to do exactly what we have done here in this example, having the task simply rewritten from scratch. The first thing that I would do is simply put 10 steps. We don't want to go to 100 steps, and we want to see, okay, we have our input. Is it these energy levels correctly populated? For example, here when we are at step 0, we should have 5, 4, blah blah blah, and here we want to print our energy levels and actually see that that's the case. And no, that's not the case. We have our energy levels completely empty. We don't scan much of that. Why is that? Our energy levels, zeros and zeros, is it to do? Let's go here and see, is this simply wrong, which is fine, or is something else. Okay, was panning wrong time, and that's why is that? Because our energy levels when we append here, we need to firstly check, because we need to append. I think where is the problem here is when we try to append the row. Let me still see. We have this 0. 1 second, because that's string. I want actually to see how the row looks. Do we even get to this row thingy? Okay, we have only empty rows, empty rows, empty rows. It seems like we don't really properly read the lines. In here we have our rows, we are appending, but is this thing for the, is this even remotely correct? Let me double check. Why would having that and having here this one and out, what would I get? Why I even get to the moment in which I have this 0 and I have this thing here. Oh, I'm going out of range on this one. However, still I need to have these printed things before that, isn't it? You know, these 10 lines that I getting as a input. Okay, that doesn't do correct. Let's simply do what I was suggesting. Okay, now we're reading the whole line. Tak, tak, tak. And here, because probably of the temperature of the thing, we can see that we are getting, yeah, more we are getting something that looks to me more reasonable. Let me say prompt 3. Okay, answer. What we get as an answer is sure much nicer. From what I can see so far, we have the Go program. We're copying it here. Up. Nice. We go here. We're pasting it here. That looks more reasonable, at least on the part where we reading. Oh, the previous one probably was fine, but when I was reading the line, in was simply empty. It's anyway, that's my mistake, but we'll stick with this one. It looks to me nicer, although the previous one we still have it in the above prompt. Sorry about that mistake, but yes, usual mistakes happen. Let me get here and have my test input sorted out. Bam. Let me get in my input not to fall in the same situation. Here I still couldn't see the nines. Okay, we start before to have nines. Okay. In this case, how our grid would look like. The things that we're trying to test is that our grid will be correct. And our grid looks, let me go back, it looks legit 5 to 3, 5 to 3, and the last one it's 5 to 6, 5 to 6. Okay, the grid looks legit. We want to put this on 10. And see what might make our flash number being 0, because here after 10 steps we'll expect our total flashes to be 240, and in our case they're zeros. First thing first, we are checking how many total flashes we have based on the grid, and we are going through the grid and counting that, but we want to count this number of flashes each time. Let me move that function int. Oh no, flashes, we have this grid and we are getting total flashes. We have our gimp. Okay, that's with our given grid. But when we go for each step, we want to go at the end of each step and count the number of flashes, and this total number of flashes should be up here, because after each step we need to add simply to this total number of flashes so far, to add the number of flashes. Okay, and if we do that and we delete this, what we get? 134, which is more promising than what I would expect, and that's after 10 steps. We are initializing and we are having step 1. Let me see how we're counting these 10 steps. Okay, we have our initial grid. We are counting what we are doing firstly. We're having this grid in which we are flashing. Oh, we need to check this. Oh, we are going through the whole grid. I think it's a bit messy, because here, if we go back to the requirement, we go to, okay, now we are increasing the energy level by 1, and we have some that are 9s. We want to check that any octopus with energy level greater than 9 flashes, okay, and this increased energy level of adjacent by 1, okay, that's absolutely fine. And every one that it's adjacent gets to energy levels above 9s, and we get to 0. I think in our case we don't want to count these grid levels, so to say. That's once we nullify it, we want to have all the one we're increasing the energy levels, and we do that correctly. At that moment we want to simply see which one are flashing, and we have this flushing thing, and how we check if something is flushing. We're checking, okay, we're going through the entire grid and checking is the thing flashing, and if it's so, we're setting it to true, which means in this flashing thing we need to actually check, okay, you're in the grid, you're flashed, how many times you flashed, number of flashes, and here we have boolean actually, and we have the integer, and here we have actually flashes, total flashes, bam, everything is perfectly fine. We have our flashes and total thing. Yeah, let's see how that changed. It didn't change much, but is that because there is a mistake? Let me see the part of the logic here, because we have our step 1. Let's see how our thing look after step 1. After step 1, how many flashes we have? Print. No. We have 0, 16, 90, 34. Okay, kind of okay, but let me try to see why is that the case, because I want to see how the flashes look, how the grid look. How many? 9. That's after doing step 1. We start getting some 9s. After step 1 we have 3, 4, 5. Here I can see you are getting at step 1. Okay, I'll do some little pause. See you in a couple of seconds. Continue. Yeah, let's see where we were here there is when we are counting and seeing which one is flashing, we're checking for all that are above 9. We have all these checks and so on, and I think that's fine. Let me look again at one example. We start with, okay, let's instead of having our traditional example that couldn't check, start with this mini example, so to say, and let's just let me close some other inputs and go here. We have our grid, we're iterating through the grid and so on, and we're checking 10 steps, so that's fine. We're reading the rows, that should be fine. Let's see if we go out of boundary. We don't, but that's absolutely fine. At the first moment we get our twos in our rows because we don't care for the stuff that it's outside of this square that is 5 by 5, and we can see the first time when we print stuff, that's once we have done one pass, we have all these 2 to 1s. No, that's the initial step. Let me see. I think that actually we're not passing through in the correct way. Before to let me do only one iteration. Here we have our print and we have our grid. Sorry about that. Print line. And when we print the line, we can see we have ones, 199, etc. And after that, when we do one pass, we are to this situation in which we are counting how many tens we have. Firstly, the number of 10 is not 25. That's wrong. Secondly, after one step, here we should have this one, and it doesn't look whatsoever as this one. And let's see what's actually wrong with it. First thing is here we need to get to the flashes, and we're doing some checks in which we are adding flashes and so on, which simply looks simply wrong. Okay, instead of again wasting a huge amount of time, let's brute force it to something that okay, this time I was asking us to provide with the format. Oh, that's interesting. Octopus. And now it's trying another. I stopped with the previous solution because it was going too much out of what we would expect. We we don't want to spend too much time. At the end of the day, we can simply do the whole thing. Does make sense, this one. Let's see, we have energy flashed. Okay, good. Reading looks fine. We have this with the steps look fine. The energy is changing, we're checking for the energy and so on. Again, it looks quite promising. Let me go the other way around and firstly run it. We're getting 0 again. Let me go to having one step. Perfectly fine. The first and most important part is here, reading the grid. Print line. Is that is the grid legit? 5. False. And up to 6 here. Okay, the grids look legit. Yeah, let's invest a little bit time in this solution. It seems again, as the previous one, promising. I don't think on that stage, when we're solving these problems, they're quite complicated. They have some subtle conditions that make it hard even for a person to solve it and so on. I think at the after the initial few days, simply a person needs to read a little bit and go back and forward to iterate on the solutions that the ChatGPT offers. And here we have this increase the energy of each octopus. Okay. In our let's go again, and this time have our baby example. We're going to the baby example. Is the baby example okay? Let's see if we can run the baby example. Okay, it will look legit. 1 1 1. The other ones are zeros. Exactly what we would expect. In the baby example, after one step, looks as that. Let's see. That's step 1. When I'm saying step 1, I mean this one. First, the energy level of each octopus increased by 1. That's done. Here, let me print the grid. Simply to verify, should be 2, 2. Yeah, 2, etc. tens. Second, then any octopus with the energy level greater than 9 flashes. is that the case. We're going through the one and we're checking, okay, this one haven't flashed, we make it to flash, and we increase the energy to the adjacent one. Let's see how it looks at the end of this step, because here we should have these 3, 4, 5, 4, 3, etc. And we have 3, 4, 5, 4, 3, and so on, which showing that the dealing with the adjacent seems to be working. After this step, okay, up to here, everything looks legit. And after this one, here we want to see that the one that flashed are reset. Is that the case? Yeah, what is this? Yeah, we have zeros and so on. Okay, that's look absolutely fantastic. Here means that this part that we are counting the total flashes, it's simply wrong. And in our case, we know about this total count of the flashes and so on. What we want to do is we are going here and we have this with the flashes, and every time when we make the flash true, we should count that. Okay, we're seeing that we have 8. 1 second, here there are like 9. Why is here 8 flashed? I'm a little bit surprised, because here if we have 0, 0, 0, we should have there 1 more. Okay, let's do it up there. I mean, okay, it's exactly the same what I would expect. But why would it be? Is this picture a little bit fake? It's 1. Why would it get here 0? I think that's not correct. Let me try with this one and double check that's correct. Think the output there simply wasn't correct. Okay, why would I get 0? Okay, let's look at this example now, which we have our test, so on, and I'm getting 0 here, which is absolutely fine. Have that at the top, and I want to but why I wouldn't oh, excuse me, I'm doing only one iteration. Okay, my number of iteration seems to be, I should get 1656 1. I'm getting 1960. Why I'm getting more than I would expect? I'm checking, okay, I'm above 10, and I'm going to flash. And here are all the ones that are really flashing, and I'm getting the same number. Is this, let me see, after 10 steps how it's then after 100 steps there have been a total of flashes. Given the starting energy level, the Dumbo octopus in your simulation, blah blah. Okay, but let me double check I'm operating with the correct one. Yeah, it didn't look like the correct one whatsoever. Now that this one looks correct. And that's my, you see here are so many different inputs, I start getting confused. Okay, that's look like my real input. What I get with my real input, this one, I mean, no, it's not correct one, which is not big surprise. And now I have this one. Let's go with this one, which is not the test one, or is the test one? Okay, it looks the test one. After I iterate 10 times, I'm getting 204. Let's see why after iterating 10 times. After 10 iteration, is this step mentioned anywhere else? No. Okay, one second here. How we count that stuff? Again, first level of each increased by 1. Then any octopus with an energy level greater than 9 flashes. Now, okay, I think unfortunately, once I flash, I should reset I and J and start from the beginning. I think that's what because here I'm getting to one block, I'm flashing, and after that I'm marking this as flashed, but after that I continue from the grid. I think in this case I actually should do j equal to 0, simply to reset the loop. Reset the outer, or start the outer loop from the beginning. The outer loop okay, much closer. Why would be off by 1? Because here, when we look at this example, is after step 10 they have total of 140 flashes. So the case, okay, let me go here. I mean, that shouldn't change anything, but let's count it here. When I'm nullifying the flashes. Total flashes. Why the total flashes are off by 1? Let me again, sorry about that, but let me go again to the demo example with this one, because this one was off with 1, and I think I got simply confused. I was off by 1. Let me give a try. Okay, I want only 1 step. Okay, now 9 now looks fine. Why would after 10 steps the other one okay, let me get again. I think it's probably something to do with the last flash, because here I have all the flashes through. I have this adjacent one, I increase them, and I will always, after having a new one that it flashes, reset the whole thing. And on theory, it's possible to have one that is with the energy. Let me see. I'm thinking that it's somehow possible to have one that is with energy above 10, but not to count it for some reason. 9. No, sorry. Think once I'm done with this one. Okay, it seems like I'm missing the last one. I mean, in this count, I should. Why I'm not counting here after the last flash? I'm a bit puzzled with that. I mean, I always can do simply like that. I think that will work correctly. Okay, let's put our legit input, put the steps to 100, and let me see what's happened. Is that doing anything? 173. No, it wasn't right. But if we had tried with our test input, okay, with our test input, it seems to be legit. Why with this input? I would assume this input has something. No, it doesn't have nines. I was thinking, let me double check the case. Here we have the input nines. No, 9, no, 8. We don't have corner dates. Is it possible because of that they have some mismatch? Total flashes. What was here when I was trying? Oh, I didn't see. Was that after 100 steps? Yeah, after 100 steps. How many? And if I have 99 steps, how many there? Okay. Looks like legit. Let me see after 100 step. How does it my grid looks at the end? Because probably that will here before to get there print and have grid after 100 steps. I have 12s here, zeros here and so on. All looks legit. I have here 1 9. Okay, 9, and after that I have 1 7, and I have 1 6, and at the end I have 6 6. Okay, it looks all damn correct. Is it anything in the condition that I'm simply missing? This increase energy level of alpha adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. And that is going as long as you have a new one that are over. And we have at most once per step. What do you mean? At most once per step. When it's 13, 14 we couldn't. And at the end of the step, okay, the energy of the one that flashed it's reset. But why would I have? I think the last time that I get inside here, um, for a new one, yeah, I still couldn't understand why, if I have this bad boy here, one 655 instead of, yeah, but why it's one less? I'm really puzzled. Can't everything is false when I'm reading them. After that, in iterating to increase their energy, I'm checking, okay, the new one, they're above 9 and so on. I'm going through the adjacent one. Once I'm, so to say, done with the adjacent one, is this because I'm missing here the adjacent one? Because what would happen if I'm this one here? I'm coming with this I and J. I'm 9 and I'm with I and J that are 9 and 9. The first thing that I'm doing is I'm having my II to be 8. I'm checking, am I smaller or equal to the one that's 10? And I have I think, okay, I'm 0. I'm also under 10 to cut the corners. Okay, unfortunately that's so legit. What will be when I'm simply here and I'm 0, 0? I have the 0, 0. I have That's minus 1, and I have this to 0. No, I have this one to 1. And I'm cutting this corner. I'm checking, okay, I'm in a range, and I increase the energy for the one that are adjacent, and that hasn't flashed anymore. I think should be like that. Not that, I think that hmm. But when I'm checking the adjacent one, I should skip the one itself. Which is so fine. No, why is with one? But why I would have, why when I check this one, it's with wow, that's completely different. It's not with one difference. Hmm. The one that are flashing. Why is this? Why is this with flashing? So different. Let me look at again the actual condition. We do firstly we increase the energy. That's fine. Then we check which one are flashing. Oh, the one that have nines. and they hasn't flashed. In our case, this case this burst continues Wonka's new octopus G level increase beyond. Oh my god. Oh my god, I need to reset the bloody thing, because here I have +1. I will start not from 0. Oh my god. My god, my god. Hey, 1 second. Okay, I need to do break outer loop, and let me put here like that. Yeah, so many. Oh, what's happened with this break outer loop? Because I'm done with this one. Okay, let me. This outer loop doesn't help either. Do I need to start from the beginning? Or again, this is doing the same kind of thing. This start to think more like a guessing game. let me do that. Break outer loop, and here I have outer loop. I'm doing all this adjacent. For God's sake, for God's sake. But here I will want this one flashed. Yeah, but I can start getting very tired of this. I might call it a day. Let me give this one. Okay. I start getting simply too confused with my resetting because they're iterating outside. For this I need to make it minus. For this one, okay, let's do it from 0 because it's the outer one, and before to increase it, it's still whooping the other one. Okay, it makes sense, although yeah, I mean, not biggest fan of this solution, but I mean, it is working, and I start getting tired. Anyway, let's see how it's get for day 11 part 2, and hope that was useful for you, and see you in the next video.